Hi friends, let us start today's name reaction series. Today we are going to discuss about the benzoin condensation reaction. So let us see what is the let us see the benzoin condensation reaction. This is a reaction of benzaldehyde to get the benzoin derivative. Benzoin derivative is the alpha hydroxy. This one is the alpha carbon to carbonyl. This is the alpha hydroxy carbonyl biaryl derivative. This is a condensation reaction. Reaction is used where the 2 mole of benzaldehyde condense to get the benzoin. So as we have seen, the benzaldehyde is converted to benzoin using the nitrile. This nitrile is used as the nucleophile in the sequence. It was discovered by Liebig and Wöhler in 1832, and there is a modern development where catalyst with the presence of nitrile has been reported by the Nikolay Zinin. This is a reaction of benzaldehyde to give the benzoin, that is a biaryl alpha hydroxycarbonyl compound. In the first step, there's a reaction between the aromatic benzaldehyde, the cyanide attack on the carbonyl group to get the cyanohydrin derivative. This cyanohydrin derivative tautomerize to get the what you call it OH cyanide. This is cyanohydrin. In the next step, the conjugate base which is formed in the reaction medium abstract this acidic proton to get the anion over here. This anion attack the second mole of an benzaldehyde, get the condensed biaryl product. The technique where initially we wouldn't prepare the anion, we couldn't abstract this proton in benzaldehyde effectively using a base to get the negative charge. So when we had the nitrile substitution over here, the proton become more acidic as compared to benzaldehyde because there is a one electron withdrawing aryl group and another one is the nitrile or cyanide group, which pulls the electron density to make this carbon more electropositive. Hence, this proton becomes highly acidic and which can be effectively picked up by the base. This technique where we reverse the polarity, in initial we are having electropositive, electronegative proton, it has been converted to electropositive and we have reversed the polarity. This technique is known as the Umpulang technique. So let us continue the mechanism. In the next step where we get the condensed product, there's a tautomerization again. This there's a protonation of this OH minus to get the hydroxy. In the next step, the conjugate base abstract this proton to get the anion on the negative charge. This anion pull back with carbonyl derivative, displacing the cyanide as a leaving group to get your benzoin condensed product. So reaction is highly interesting. It is whole depend upon the Umfulong technology. I may be having one more video on this Umfulong. It is interesting where it is in general sense, we reverse the polarity of an proton and with the help of this reverse polarity, it can be coupled with another kind of derivatives. So there is a modern development. This one is reported by the Laport, where they have used the thiazolium as the thiazolium salt as a catalyst for the benzoin condensation reaction. There is another one where they have similar kind of an catalyst where instead of thiazolium, imidazolium catalyst has been developed. And this work has been reported in the Journal of Chemistry Research in 2022, in 2002. So what is the use of this catalyst? First of all, we will see the catalysts are used to increase the productivity, to increase the yield, to increase the overall conversion from what you call as increase the yield. First of all, that is one of the phenomena. Even though some of the substitution which cannot be effectively stabilized in the reaction sequence, that can be stabilized with the help of effective catalyst. Another one is the discovery of this cyclodextrin. These are the macrocyclic molecules. They are used as the catalyst for the benzoin condensation reaction. The next slide. we will see the application of benzoin condensation reaction. There are many applications reported. First one is the organic synthesis, as we have seen the synthesis where number of new functional conversion techniques has been used. So if anybody wants to prepare the biaryl alpha hydroxy carbonyl compound, benzoin condensation can be effectively used. Next one is the polymer chemistry. This is an excellent technique where in polymer industry, they have using this benzoin condensation, they can prepare a polymer with the new monomer. New monomer can be easily prepared by the substitution on the aldehyde, and that can be effectively produce the polymer with the help of new types of monomer. Another one is the medicinal chemistry. So benzoin condensation is generally used in medicinal chemistry to introduce a chiral center over here. This is one of the examples where we have seen the traditional benzoin condensation reaction. We get the alpha hydroxy carbonyl compound over here. The star mark is the chiral carbon over here. So while doing the routine synthesis by medicinal chemistry, a chiral center can be introduced during the sequence of reaction. So this is an excellent technique. Furthermore, this hydroxy can be converted to O-methyl, and we can have a different substitution or different functional group conversion having this chiral center intact. So there is a recent discovery made in this benzoin condensation. Effectively, we can control the chiral chemistry over here. There are modern new chiral auxiliaries and chiral techniques has been developed. Thank you guys.